today we will design today we'll use an algorithm for designing programs or designing systems, let's say, and we'll start from zoo. So there are different animals in the zoo, each of which makes unique sounds and moves in its own way. For example, an elephant trumpets and walks. Alright, let me rename this. So first step is to understand the task. So we define the goal and entities. So our goal is to design a zoo system. So design a zoo system. So design a zoo system that can accept any animals to the zoo and each animal has its own properties, right? So elephant can trumpet and walk, and bird chirps and flies. So we design a system that can work with any animal, add them to zoo, and then show how they make sounds and move. So what entities do we have? We have a zoo, we have an elephant, we have a bird, and what else? So that is it, basically a zoo, elephant, bird. Animal will be a parent class for the elephant and bird. So, alright. The second step is to define the properties and actions. So let's start from zoo. So what properties does a zoo have in this case? No properties, but it has some actions. So let's say like minus sign. Actions. So zoo can accept animal, right? So something like add animal, right? What else? So we can add animal to zoo, right? Then we have elephant, or let's say animal. Since animal is a parent class, so we'll start from animal. Animal has what properties? basically no properties, and the animal has actions like make sound. Let me use a camel case. Make sound. Also, it will have an action move, right? So let me also rename add animal. Alright. Then we will have an elephant. So elephant does not have any properties. So according to the task, elephant can trumpet and walk, so it has only actions. So we skip the property part, and so here we'll have a polymorphism. So again, it's the same, it can make sound, but I will write trumpet, and walk. Alright, and also we have a bird. Let me make it like this. So an elephant, we have a bird, so bird, and bird can chirp, it can chirp and fly. Alright. Let me actually make it look a little bit better. So something like this, we have elephant and bird. Alright, so we define the actions. We don't have any properties in this case. Now the next step is to define the relationships between the entities. So here we can see we have hierarchy. What hierarchy do we have? We have animal. Animal hierarchy to a bird, an elephant. So bird and elephant will extend the class animal. Alright. Also we have the relationships such as aggregation, also called association. So aggregation is aggregation is a weak ownership, so it means that two entities can coexist and they do not depend on each other. So what aggregation do we have in this case? Elephant and bird, we can say, so these animals, they can exist. Elephant and bird. So elephant and bird, they can coexist and they do not depend on each other. But composition in this case would be zoo and animal. So if we remove zoo, there will be no animals. I mean, when we talk about the animals, we talk about the animals that are in that zoo. So, not the animals in general, but the animals that are uh, in that specific zoo. So, if we remove that zoo, all the animals will be removed as well because they are stored in that zoo, let's say. So, a zoo and animal. Composition, relationship. Alright, and the next step is we will draw the diagrams. So we have animal as a parent class. Animal, an animal has actions like make sound, make sound, move, action move, and the elephant and bird, they will extend those methods. So elephant and bird, it will inherit all the methods from an animal, and what an elephant will do is that it will trumpet, and it can walk. And bird can chirp and fly. I mean, chirp and fly. So what do we have in this case? We have an inheritance, right? So a parent class animal has descendants elephant and bird. So this is the inheritance. I guess the methods will be private, so I mean the methods will be public, so we don't have any encapsulation in this case. What else do we have? We have an entity zoo, so let me define it here. Zoo will have method add animal, so zoo will have a method add animal that will allow us to add animal to the animal class, and we can also define it here as well. Add animal. So when we call the method add animal from the zoo class, the method from animal class will be called, add animal will be called, and we can extend the class animal, create another animal in the future. So in this case, zoo is, the zoo class is an abstract class. The method add animal, we don't know how this method works. Actually, also there is another instance of abstraction here. So when we call the method make sound, we don't know which animal is that. Or when we call the method move, it can be any animal with its unique method. So a bird will chirp and an elephant will trumpet, right? So, and also we have a polymorphism. Polymorphism is exactly the same. So the method make sound is overridden in the subclasses like elephant, trumpets, and bird chirps. So this is basically the process of overriding the method of a parent class, and the method move is overridden as walk and fly in descendants. So this is called a polymorphism. Alright. So let's move to the next task. Pet management system. There are different types of pets in the system, each of which requires unique care. For example, a dog is walking and eating dry food, cat plays and eats wet food. It's necessary to design a system that accepts any pet and allows interaction with it, for example, feeding, walking, or playing, taking into account the characteristics of each species. So let's go and create another So again, we start from the first step. We define the goal and entities. So the goal is to design a pet system. Design a pet system, right? So pet management system. Okay. Pet management system that will allow us to add pets to the system, accept any pet, interact with it, like feeding, walking, or playing, and take into account each characteristics of, taking into account the characteristics of each species. Alright, so what entities do we have? We have pet, right? So we have pets. We have dog, cat. So we have dog, cat, and also let's say we have a manager. It's a manager. Alright. The next step is to define the properties and actions. So, what entities do we have? We have a pet, right? Pet. What properties does a pet have? So again, no properties. It has actions like move and eat. So move and eat. Then we have a dog. So dog, what properties does our dog have? So no properties. Okay, so no properties, but it has actions. Walk and eat dry food. So walk say dry food. Right, and also we have a cat. Cat, again, no properties are given. Cat can play and eat wet food. So cat can also walk, but it can also play. So maybe we can make the play as a private method, as a unique action of a cat, and it eats wet food. So wet food. All right. And also we have a manager. So we have a manager, right? Manager. What properties does manager have? No properties. Let's actually not call it a manager, but let's say some kind of a pet management. Pet management, some abstract. Pet management. So again, no properties, but we can feed the animal. I mean the pet. We can play with the pet. Also, it allows it accepts any pet. So add pet. So these actions. Alright. The next step is to define the relationships between the entities. So what hierarchy do we have in this case? We have a pet, and pet is a parent class for the entities like dog and cat. So what aggregation do we have in this case? So dog and cat, they can exist and they do not depend on each other. So if we remove dog, cat will stay. If we remove cat, dog will stay. It will not affect. So we can say dog and cat. And what composition do we have? So if we remove pet, the dog and cat will be gone also. So, or we can say pet management and pet. So there can be no pet management without pets. So let's say pet management and pet. So this is a composition. Alright, and the next step is to design interaction interface. Let me go down a little bit like this. that has actions like move and eat. So move, eat, and we have descendants like cat and dog. So cat can play and eat wet food. So cat can play and eat wet food. And also we have a dog. Dog can walk and eat dry food. So dog walks and eat dry food. So walk and eat dry food. And also we have a pet management. So pet management. Pet management can allow us to interact with the pets. So we can play with the pets. We can feed our pets. So we can feed and we can add pet to the system. So add pet. And we should also define this method in the pet class. So add pet, that will allow us to add the pet, a new pet. So again we have inheritance. We have the descendant classes. Parent class pet has descendant classes cat and dog. So this is the inheritance OP principle. Then we have polymorphism as well, because the methods move and eat are overridden in the subclasses. So cat implements the method eat differently, and dog also implements it differently. And dog also overrides the method move. In this case we said that play will be some unique action, so we can make it private. So this is encapsulation. What else? We have abstraction here. So when we call the method add pet from pet management system, we call the method from the pet class, which allows us to create a new pet. To add the pet to the system and creates a new class of some new pet, maybe some parrot. And we can call the methods play and feed of each entity. For example, if it's a dog, it will walk. If it's a cat, it will play or eat wet food. The dog will eat dry food when we call the feed method. So when we call the feed method, we don't know which method, which animal's method will be called. So this is abstraction. And pet is an abstract class, because we will not create there is no such an entity as pet. It can either be some cat, dog, or some specific pet. So we cannot create, and we will not create an instance of the class pet. So this is an abstract class. Alright. Now let's move to the next task. Restaurant management. So the restaurant has different dishes, each of which has its own characteristics. For example, a hot dish is served with temperature indication. The drink is served with a volume indicated. It's necessary to design a system that allows adding dishes to a restaurant menu and display their description, taking into account specific characteristics, for example, temperature for hot dishes or volume for drinks. Okay, so again we use the same principle. We start from defining the entities and the goal. So what is the goal in this case is to design a restaurant management system. Design a restaurant management system. Alright. We have entities like restaurant. We have dish, hot dish. We have drinks. What else? Alright, I think that is it. And now, second step is to describe the properties and actions. So we define the properties and actions. Let's start from the restaurant. So restaurant, what properties does a restaurant have? So restaurant will be some kind of a manager here, as a manager that will allow us to add dishes, some kind of abstraction. So restaurant has different dishes, right? So properties, we can say dish and dishes. And what actions do we have? So we can add dish to restaurant. We can display the information. So display or just display information. Then we have dish. So dish, what properties does our dish have? No properties, so properties are not given. And what actions? What actions do we have? then serve. Okay, serve dish. Also we have hot dish. Hot dish has properties like temperature, right? So it has temperature. And again we can serve. So let's keep it simple. Say just serve. So serve with temperature indication. And also we have drinks, which has property volume. And action also serve, but with volume indication. Let me write it here. Volume with temperature. Okay. So now we define all the entities. We can move to the next step, is the relationships between the entities. So hierarchy, what hierarchy do we have? We have a dish, and from dish we have descendants like hot dish, and drink is also some part of a dish, so drinks. Aggregation, I think we can use hot dish and drinks as aggregation because drinks and hot dishes, they do not depend on each other, and they can exist if we remove one of them. So hot dish and drink. Actually, we can rename this. This is not a drink, let's say beverage. Beverage. Alright, and composition. We could say a restaurant and dish, but it wouldn't be that much dominant composition actually. But we can say restaurant and dish, and also we can take dish and hot dish. So if we remove restaurant, there will be no dish, right? So let's actually, dish and hot dish is not a good example. A restaurant would not be a restaurant without dishes. The main purpose of restaurant is to serve the dishes. So restaurant and dish have a composition relationship. Now let's move to the next task. The next step, where we define the interaction interface. So we have a dish as a parent class. So dish has actions like serve, serve dish, and also we can add dish. Let's also add it to our table. Add dish. And we have descendants from our dish class is hot dish and beverage. So hot dish and beverage. So a hot dish has property temperature, and this is will be a private field, right? So this is a private field, and it has the method serve. So serve with temperature indication. Right, and beverage has the field volume, and also it's a private field, and it also has a method serve. And also we have a restaurant as well, so a restaurant as a management system. So restaurant. Restaurant has dishes, right? Maybe some list of dishes. Restaurant has methods. Add dish and display information. Display information about a specific dish. Okay, so add dish and display information. Right. So in this case we can see the inheritance principle, where we have a parent class dish and a hot dish and beverage. They are descendants of the class dish, and encapsulation we can see in this case. The encapsulations, we have fields that are private, so we can access those using getters and setters. So this is encapsulation, and we have also polymorphism, where see if I can show it like this. Okay, so we have the method serve that is implemented differently depending on the dish. So hot dish is served with temperature indication, but the beverage is served with volume indication. So this is a polymorphism. And dish itself is an abstract class, so we cannot have an instance of dish. We can only have a specific dish like hot dish or beverage. So this is an abstract class, and we have an abstraction here. Abstraction like add dish or display information. When we call the method display information, the information will be displayed depending on the type of the dish. So if it's either a hot dish or beverage. Now let's move to the next task. Aquarium. So there are different types of fish and sea creatures in the aquarium, each with its own characteristics. For example, a shark swims quickly and aggressively while a starfish slowly crawls along the bottom. It's necessary to design a system that can contain different sea creatures, add them to the aquarium, and demonstrate their behavior and movements. Alright, let me create a new sheet. And let's start from our first step, define the goal. Here we want to create an aquarium, right? So we want to create an aquarium. A system. Aquarium is a system that can contain different sea creatures. So shortly we can say design aquarium that can contain sea creatures. What entities do we have? We have an aquarium, we have shark, starfish, and those are our entities. Now let's move to the next step where we define the properties and actions. So let's define the properties and actions. So what entity do we have? We have aquarium. Let's start from aquarium. Alright, aquarium. Aquarium. Properties are not given. And actions. So what can we do with aquarium? We can add fish, right? So we can add fish. Remove fish. What else? So add, remove fish. Alright. Then we have shark. And also, let's not forget we have a fish as well. Fish itself is also an entity. So let me start with fish. Fish. What properties? No properties. And actions. So fish can, let's see. So it can move, right? Fish can move, or we can say swim. So then we have shark. So shark moves aggressively and fast, so swims quickly and aggressively. So shark swims quickly and aggressively. And then we have starfish. I'm gonna take it like this. It does not have properties. So starfish can also it can move slowly. So right, starfish slowly crawls. So it crawls slowly. Right. Okay, let's keep it like this. So we have starfish, like I said, it crawls slowly. The next step is to define the relationships between the entities. So, do we have a hierarchy? Yes. So we have a fish as a parent class, and fish has descendants, shark and starfish, right? Then aggregation. So shark and starfish, they can coexist and they do not depend on each other. So if we remove shark, it does not necessarily mean that we will remove a starfish as well. So we can say shark and starfish aggregation. And then what we have as a composition, we can say aquarium and fish. So aquarium and fish. So there is no aquarium without a fish. I mean, and fish cannot exist without an aquarium. So they depend on each other. Alright, the next step is to design an interaction interface. So let's start fish. Fish is a parent class, and what properties does our fish have? No properties, but fish can move, right? Can move, and it can have a method add fish. Also, we need to add it here, like add fish. Add fish. Alright, then we have shark and starfish. So shark and starfish. What does shark do? Shark swims, right? So shark swims quickly and aggressively. So swim. Quickly, aggressive. Alright, and starfish, it crawls slowly. crawls slowly. Alright, and then we have our aquarium. So aquarium will be like an abstraction. Aquarium. So aquarium can add fish, remove fish. So add fish, remove fish, and also demonstrate their behavior and movements. So demonstrate. Let's say show. Okay, let's keep demonstrate. Demonstrate. Demonstrate behavior. So demonstrate behavior will call the method move that will call it depending on if it's a shark, it swims quickly, it will print out a message like swims quickly and aggressively, and if it's a starfish, then it will print out the message crawls slowly. Alright, what else? Our aquarium can contain any sea creatures, so we can add them, add and remove, demonstrate their behavior and movements. Alright, so which OP principles do we have in this case? There's no encapsulation. So we can see the inheritance. Fish has a parent class, has descendants shark and starfish. So shark and starfish, they inherit the methods move and move. Actually, we have an encapsulation. Add fish method can be private so that the child classes do not inherit this method, and this can be encapsulation. Like I said, the inheritance is that the child classes inherit the method move and redefine it, and here when they redefine the methods move, when they print different messages, it's a polymorphism, and when we call the method add fish from the aquarium, we actually refer to the method in the fish class that has the logic behind. I mean, so when we add the fish, or when we say demonstrate behavior, we actually don't know the real implementation of this, and depending on the type of the object, if it's a starfish or shark, the related message will be printed to the console. So this is the abstraction, and fish itself is an abstract class, since we will not be creating any instance of class fish, and only the descendants can have the instances. Alright, so now we can move to the next task. A farm contains a variety of livestock, each requiring specific care. For example, a cow produces milk and requires pasture in the meadow. A chicken lays eggs and requires a feeder with grain. A system must be developed that allows for the management of different types of livestock, their care, example feeding, cleaning, or grazing, taking into account the individual requirements of each animal. So we're asked to design a farm, right? So let's create a new sheet. We're asked to design a farm. The first step is to define the goal and entities again. So the goal is to design a farm. design a form. Entities. So we have a form, we have a cow, we have a chicken, chicken, and livestock. Alright, so these are our entities. The next step is to define the properties and actions. So we have, let's start from the entity form. Form, what properties does a form have? So form does not have any properties, but it has some actions that we can perform. So we can feed, right? Feed, clean, graze, feed, clean, graze, feed, clean, graze, and that's it. Management of livestock, let's say add livestock. Alright, the second entity, let's take a livestock. What properties does a livestock have? So livestock, so no properties. What actions? So we can have feed, right? Feed. Then we have our chicken. So chicken also does not have any properties. It's not given. And chicken can lay eggs. What else? Chicken. Feed with grain, so we should also feed. So feed with grain. Feeding grain. Also we have a cow. does not have any properties. But cow can give milk, right? So produce milk. And requires pasture in the meadow. So give milk and pasture. Alright, now let's move to the next task. Is the relationships between the entities. So what hierarchy do we have? We have a livestock, and livestock as a parent class for the classes chicken and cow. For aggregation, what can we take? We can take chicken and cow. So chicken and cow, they can coexist and they do not depend on each other. For composition, farm and livestock. So if there is no farm, if we remove farm, we remove livestock as well. Livestock. Okay, and the next step is to design an interaction interface. So we have our livestock as a parent class. Livestock. What properties and methods does our livestock have? So feed and add livestock. Just keep it simple. Then we have child classes like chicken and cow. Chicken and cow. So chicken can lay eggs. And should feed our chicken with grain. So feed. Actually, chicken is not responsible for the feeding. The farm is responsible for feeding chicken. So chicken has a single responsibility, laying eggs. So we'll keep only one action for our chicken. And also cow is only responsible for giving a milk. Give milk. And cow is not responsible for pasturing. So here we'll define our farm as an abstraction, and we should be able to feed the livestock, clean the livestock, graze, the livestock, and add livestock. Alright, so we can see the inheritance, there's no encapsulation. We can see the inheritance livestock being as a parent class, and chicken and cow, they're descendants of class livestock. And the livestock itself is an abstract class because we will not create an instance of class livestock. And we can see the abstract methods. So abstraction, when we call the method feed, we call the method feed of a specific animal, of a specific livestock, and so depending on the class, the according method feed will be executed. If it's a chicken, then chicken requires a feeder with grain, so feed chicken with grains. If it's a cow, then cow requires a pasture in the meadow, so when we graze a cow, call the method graze, we need to graze a cow in a meadow, so pasture a cow in the meadow. And when we call the add livestock, the add method is executed, and we can extend the class livestock. So this is it. Now let's go to the next task, botanical garden. A botanical garden contains many different types of plants, each requiring specific care. For example, an orchid requires high humidity and shade, while cactus requires lots of light and infrequent watering. A system must be created that can manage the variety of plants, add them to the garden, and provide the necessary care based on their preference. So let's create a new sheet. The first step is to define the goal and entities. So the goal is to design a system, design a botanical garden. So design a botanical garden. So what entities do we have? We have a botanical garden. So botanical garden, orchid, cactus. Let's go and write them. So botanical garden, orchid, cactus, what else? And let's say plant, a plant. So the next step is to define the properties and actions. So we have our entity, botanical garden. What property does a botanical garden have? So a botanical garden contains many different types of plants. Has method add. So basically no properties are given. for the actions, should be able to add plant, add plant, add plant and provide care, let's say. Provide care. So the next entity is orchid. So orchid, what properties does an orchid have? Orchid requires high humidity and shade. So this is related to the care. This is the way how we take care of the orchid. Cactus requires lots of light and frequent watering. So let's actually start from the plant. So plant as a general, it will have properties like water frequency. So water frequency and light requirements. And actions. What actions can we have? Provide care, you can say. Provide care. So then we go to our orchid. So orchid requires high humidity and shade. So again, the same properties. So water frequency and light, which we will copy from the plant. So water frequency and light requirements, and the same action, provide care. And also we have cactus. So cactus, again, water frequency and light requirements for properties, and actions, provide care. So cactus requires lots of light and infrequent watering. Alright, so the next step is to define the relationships between the entities. So what hierarchy do we have? Have a plant as a parent class for the descendants like orchid and cactus. For aggregation, orchid and cactus. So they can coexist and they do not depend on each other. And for composition, you can say botanical garden, and plant. Now the next step is to design an interaction interface. So we start from plant. Plant has properties like water frequency and light requirements. So you can take them. And it has a method, provide care. So provide care. And then we have the child classes, orchid and cactus. So orchid has the same properties, so water frequency and light requirements, and provide care. Cactus also has the method provide care. Properties water frequency and light requirements. And also we have our botanical garden. So botanical garden that has actions like add plant and provide care. So there's no encapsulation. The inheritance, you can see the parent class plant has child classes orchid and cactus, so this is the inheritance. Add plant is an abstract method, so this is the abstraction, and provide care. These are the abstract methods. The class plant is an abstract class. We will not be creating an instances of the class plant. We can only extend the class. And polymorphism for the methods provide care. So depending on the class. So for orchid, we need a high water frequency, and for orchid needs shade, so low light and high water frequency. For cactus, it's low water frequency and high light. So cactus requires lots of light and infrequent watering. Alright, so let's create another sheet and let's move to the next task. Amusement park. An amusement park has different rides, each offering a unique experience and requiring specific maintenance. For example, roller coasters require regular safety checks, while carousels require frequent maintenance. A system must be designed that controls the various rides, ensures their safe operation, and provides visitors with information about each ride. So let's start from defining the goal and entities. So the goal is to design a system, design an amusement system. So we have entities, the amusement park, I guess, amusement park. So amusement park. So we have entities amusement park. Then we have roller coaster. And carousel. And the ride itself. Okay, the next step is to define properties and actions. So let's start from amusement park. Amusement park. No properties are given, and the actions. So amusement park. Let's say control right, so it should be able to control the right. Then ride information. So ride info. All right. So the next entity is roller coaster. So roller coaster. What property does a roller coaster have? Safety checks. So the next entity is a roller coaster. So roller coaster. No properties are given, and actions. So roller coaster must be able to operate. So they have a method operate, and maintenance, right? So roller coasters require regular safety checks, and carousels require frequent maintenance. So we can say perform maintenance. Alright. The next entity is carousel. So carousel. No properties are given. Actually, we can say name, so that it wouldn't be empty. Name. So name. Then again, we have the method operate and perform maintenance. So depending on the ride, so if it's a roller coaster, then roller coaster so roller coaster for the method perform maintenance will print out the message roller coasters require regular safety checks, and for the carousel the method perform maintenance will print out carousels require frequent maintenance. And for the method operate, roller coaster can print out the message runs at high speed, and for the carousel we can say spins gently. So, and the last entity is the ride. So let's not forget the ride. So ride is a parent class for roller coaster and carousel, so it also has a name and the same actions. So let's move to the next step. Next step is to define the relationships between the entities. So hierarchy in this case is ride as a parent class for the classes roller coaster and carousel. Aggregation, we can say carousel and roller coaster, so they can exist and they do not depend on each other. So if we remove carousel, does not mean that the roller coaster will be removed as well. So roller coaster. And for composition, we can say that the ride depends on the amusement park. So if we remove amusement park, the ride will disappear as well. So amusement park and ride. Alright, now the next step is to define the interaction interface. So we have a ride as a parent class, and ride has a property name which is private, so encapsulation, and then it has method operate and perform maintenance. Also ride has another method, show information, so show info. Like this. So show information. So we have show information, which is a private method as well. Then we have operate, which is public. Public method, and perform maintenance. Which is also public. And so we have two descendants, which is carousel, and carousel has a name as well, name which is private, and carousel has the same methods, operate and perform maintenance. So in this case operate would print out the message message spins, let me put it like this, spins gently. And for the maintenance, we said that carousels require frequent maintenance. So we can say, we can print out the message. Require frequent maintenance. Like this. And the next one is a roller coaster. Which also has a name. It has the same methods operate, which will print out runs at high speed, and the method perform maintenance will print out the message require regular safety checks. Regular safety checks. Alright, and we have our amusement park, which will be an abstract class. Amusement park. Amusement park is not an abstract class, but it has a it implements the abstraction, so there is an abstraction in the methods. So when we call the method control right, the method will be executed depending on the right. So if it's a carousel, then it will call the method operate, which will print out the message spins gently. If it's a roller coaster, then it will print out the message runs at high speed. So, and ride, the method ride information refers to the method show information, which will print out the message. So depending on the roller coaster, if it's a carousel or roller coaster. So yes, so in this case we have inheritance, that carousel and roller coaster, they extend the class ride. So class ride itself is an abstract class. We cannot create an instance of class ride, and it has private field name, which is the encapsulation. You can access this field using the getters and change the name using setters. Then we have inherited the methods operate and perform maintenance and implement, override this method. This method has different implementations depending on the class. So carousel has its own implementation and roller coaster has another implementation of the same method operate that was inherited from the parent class ride, and the same for perform maintenance. So this is the polymorphism in action. Alright, now let's go to our last task, museum. So the museum displays various exhibits, each with its own history and requiring special storage conditions. For example, ancient manuscripts require controlled humidity and temperature. So we have our entity manuscript and sculpture. So, and we have entity museum. And the parent class for the manuscript and sculpture is exhibit. So we'll develop a system that manages exhibits, ensures their safety, and provides visitors with information about each item. So let's define our goal and entities. So our goal to design a museum system, a museum, right? A museum. Yes, so we have a museum system. Then we have entities, museum. We have exhibits. We can say exhibit. Then we have sculpture and manuscript. Alright, so these are our entities. The next step is to define the properties and actions. So we have our entity museum. Museum has what properties? So museum can display the information. So museum will have method display. Alright. So what else do we have? So we can manage the exhibit, so method manage probably. Let's say manage. So we have a method manage, right? No properties are given. The next entity is the exhibit. So exhibit has a name, right? It's probably name. Action, show info. What else do we have? So exhibits, each with its own history. Storage. Alright. So it has a method storage, show info. Alright, so method show info and storage. Method storage that will print out the according message. Then we have sculpture. Sculpture has the same method name, the property name, and method storage that will be overridden. Alright. So sculpture will print out the message. Regular restoration. Storage, and also we were asked to display the name of the exhibit. and its history. So let's add another property to our exhibit, history. So history, and our sculpture will have the property history, and also we'll print out, we'll have another method, let's say display, that will show the history. And to avoid the misunderstanding, the matches with the methods, let's rename the method display to exhibit info. Alright, so sculpture will have properties name and history, and actions storage. So sculptures require regular restoration, so this message will be printed. And for manuscripts, we'll print out this message: require controlled humidity and temperature. So storage and display, that will show the history of the sculpture. The next one is manuscript. And it also has properties name and history, and the same methods that will be overridden. So storage and display. Storage will print out the message about the conditions in which the exhibit manuscript should be stored, and display will print out the history of the manuscript. Alright, the next step is to define the relationships between the entities. So we have hierarchy, exhibit as a parent class, and it has descendants, sculpture and manuscript. For aggregation, we can have sculpture and manuscript, because they can coexist and they don't depend on each other. For composition, we can say museum and exhibit. So these two, exhibit cannot exist without a museum, right? The last step is to draw the interaction interface. So we have our parent class exhibit, that has property name, which is private, encapsulation in action here, and has history. And then it has method show information. So let me paste it here to save some memory, save some place to write our methods. So next we have the method show info, show information. Alright, method storage, that will print out the required conditions, and method display, that will print the history of the exhibit. The child of this class will be manuscript and sculpture. So manuscript also has name and history, inherits these properties. History, and has the same methods: storage and display. The same for sculpture. So sculpture has a name, history, properties, and actions: storage and display. Display, correct. So, and we have our museum. Museum does not have properties, it has the action exhibit info that will print out the information about specific exhibits, and method manage. So manage refers to the method storage that will print out the related message depending on the class. So if it's a manuscript, then we'll print out the message require controlled humidity and temperature. If it's a sculpture, then we'll print out require regular restoration. And exhibit info refers to the method show info, which will print out the information about the exhibit. So this is abstraction. Abstraction when is an OP principle that hides the complex implementation details. So in this case, we don't know how the method exhibit info is implemented for the each class. We just call the method exhibit info, and the related message is printed depending on the class, and the same for manage. So it's not related to a specific class, it's an abstraction. And inheritance. So we have child classes that inherit the properties and actions of a parent class exhibit. Encapsulation, because of our properties have a private access modifier. And the polymorphism is that the same methods, storage and display, is overridden in the child classes, so they have their own implementation. So this was the last task, right? Yes. Thank you for watching.